Hi there. Today we're going to do a review of the GW INSTEK GPD-3303S DC power supply. It's a 3-channel power supply. It's got 2 variables and 1 variable slash fixed. It goes from 2.5 to 3.3 to 5 volts at 3 amps, and you can just switch back and forth from this switch. These are completely variable. They go from 32 volts, 3.2 amps, down to 1 millivolt and 1 milliamp. So it's got a really broad range. I bought it because I have a project that's going to need an Arduino power, and it's also going to use 12 volts. So I needed something that could do both of those things. So this looks really good for an Arduino power supply, and then these of course are really nice for the 12 volt portion of my project. I looked at other power supplies, and of course if you're on YouTube you know there's a million of them, and most people are reviewing the $50 ones, maybe $100 ones, and I just looked at those reviews and I'm like, well, I'm probably going to need 2 of those, and I'm into it right there, give or take $100. So I started looking around and seeing if there was something else, and I stumbled across this INSTEK model on eBay, and they were selling them for dirt cheap. If you buy one of these things new, you know, I don't want to say, I've seen prices clear up to $500, $400, $300. I paid $200 for this one. It's new in an open box. If you buy them used, and we're back. You know, you just can't do anything without getting interrupted nowadays. Anyway, if you buy them used, I see them going on eBay from $100, $130. You know, it just kind of depends. You know, eBay is sort of a mixed bag. You never really know what you're going to get. But for $200, again, I've said it in my other videos, I will buy a really nice tool that's going to last me forever, rather than skimping on a cheap tool that I hate. I've said it before, it's better to cry once when you buy it than every time you get it out to use it. So, that said, how does this work? Well, it's got obviously the display screens. It's got a good deal of accuracy on the screens. It has 4 memory locations. It's got a lock button. Channel 1 and channel 2 is how you select the switches, or these rotaries, to set their voltage and amperage. You can share these. You can get sync these together and get double the voltage at the same amperage, or the same double the amperage. So you can go up to 60 volts with 3.2 amps, or you can do 32 volts with 6.4 amps. So that's that. And then the output button, just push that to output. These rotary knobs, as you watch, I've chosen channel 1, so this will change this. Right now it's on coarse, so it's going to change it up at 100 millivolt changes. And if I turn it quickly, it moves quickly. So it's not like you have to turn this thing endlessly to get to the higher voltages. And then if you get, say if I wanted to do, well, since I've got a 12 volt project, let's just take this thing to 12 volts. So now I'm going to move to fine. I just push that button in, and there we go. There's 12 volts. Same thing down here. If I wanted to go, probably this project's going to use around 2.5 amps. So if I take it to 3, and again I can adjust that. So this doesn't require you to short it together. You can set it as you want it. When you like I've got here, you can see I have no inputs on it. And then if I like, wow, I'm going to use this, I'm going to have 32 volts just for example, and I'm going to have 12 volts, and I want to be able to come right back to that. I can program this. I just press and hold. So now I've just saved that in memory location 3. You can see this is how it was configured. I had it fine on both, and channel 1 was the one that I was setting. If I do make a change to channel 1, you notice that it dropped out of memory mode, and if I push memory, then it goes back. So there's memory 1, memory 2, and you can see it just remembers every configuration as it was set when you set that memory mode. So as far as adjusting this is concerned, it's really easy, and like I say, there's kind of a little detent in there, so it's like notch, 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 and then if you go onto fine mode, you can just turn it a little bit at a time, or if you want to move a little bit more quickly, you can zoom right on into the exact voltage that you want to use. Of course, it supports constant voltage or constant current mode. So that's kind of the display of the front of it. We'll get into the back end and we'll take the cover off, and then I'll do some electrical tests on it so you can see how it performs on the oscilloscope. The other thing it comes with if you buy it new is it has 3 of these power leads. It uses standard 3mm banana clip jacks. The leads that it comes with are really nice silicone, nice and flexible. It also comes with 2 of these that have this, horseshoe. Yeah, that's a horseshoe. So you can slip that in behind the jacks and still have the banana lead. It has a shorting clip. I don't know what you'd use that for because it doesn't go over any of the output jacks, so not quite sure what that's about. It comes with a packing list, and it comes with this book, the power supply book, and it's fairly detailed. It's all in English. You can tell it's translated from Chinese, but it's 45, 50 pages of instructions on how to use it, and relatively clear for those of us that maybe not super expert at that. Okay, we're set up to trigger on power on and voltage changes to see if there's any overshoots. These wires go up to a trailer light, one of those with the brake and turn signal on it. Since my application is an automotive lighting application, that seems like a really good use load. I've got this ground lead and then the oscilloscope probe plugged into these wires that are into the output. Of course, that means I've got a ton of common mode noise. You add on top of that the lights that are lighting us and the power bricks that power the internet that are right behind this. Needless to say, there's a bunch of noise. And also note, if you bring the internet down in this house, you're going to have a grumpy family. So we'll just go with what we've got. The oscilloscope is set to trigger at 160 millivolts. So let's click it on and see what happens. And nothing. So what that tells us is there are no spikes greater than 160 millivolts above 0. So I think we're in pretty good shape. Okay, we're going to do the power on voltage when it turns on. My load is 2.7, 2.6 amps, so with 3 amps we'll be able to stay in the constant voltage mode. And all right, let's turn it on, see what happens. Okay, and if we zoom in on that at 2 volts per division and 500 milliseconds, it looks really good. There's a little blip right there at around 4 volts, but nothing to get excited about. Let's look at the top end of the chart here. We'll zoom it down so when we go in we can see a little better. Yeah, there's nothing there. perfectly flat. Hits 12 volts and it's done. No overshoot whatsoever. And on the other side of the equation, when we turn it off, yeah, it just falls out of the sky. Flat, nothing to it. No overshoots in either direction. Okay, we're going to do a constant current test now. 12 volts, and we're going to go to 2 amps. So here we go. And looks pretty good. Zoom in. Take the voltage up a bit. Yeah, there's a little bit of a spike there right at the beginning. It takes it up to 3 volts. But since we're headed up to 7 volts in this example, nowhere near the top. So now we're going to zoom in here. And again, when you turn the power off, it just falls off the cliff and basically straight down. No overshoots, undershoots, or anything on the way down. This test is to see what happens as you increase the voltage under constant voltage mode. So I have my amperage set to 3 amps. Right now it's set to 0 volts. When we turn on the output, it should trigger the regal and we'll just watch it. I'm just going to crank it up to around 15 volts and we can see if it does any jumping or overshooting as you're doing that. So contact. All right, so we took that up to 16.6 volts. Let's zoom in on that and see if there was any silliness going on. No, nice stair steps. You can see sometimes it depends on how quickly you turn. Like right there's just a little bit of a change, more changes. Bottom line though is, yeah, there's no overshooting. It's just nicely climbing and going exactly where it needs to go without a lot of silliness. All right, this test is to test the amperage. We start out with the limit of 12 volts and we're starting off with 0 amps. Set this guy to trigger and away we go. Here comes our voltage and turn it up fairly quick and then a constant voltage and then we'll go all the way back down to nothing. Now, let's zoom in on this, see if there's any silliness going on. Nope. No spikes, just smoothly climbing, and the other end as it comes down. Again, there's kind of a little curve as it drops off on the constant current mode, but again, no spikes. All right, now we're going to move on to voltage measurements. We still have the same load up there, and there's an old saying that says a man with 2 watches never knows what time it is. Yeah, a man with 2 multimeters or 2 voltmeters really never knows what the voltage is. So are we measuring 12.3 being sent up to that, or 11.988? If you do the math in the back of the manual, it says that it should be plus or minus 4 millivolts, and that's give or take 14 millivolts difference. So which is right? Is that right or is that right? This is a $500 street price power supply. This is a $40 street price multimeter. You know, I don't know. For me, it's probably not that big of an issue because I'm doing an automotive project that's going to be varying volts, and I'm not going to be too worried about 14 millivolts. One thing that this does, however, is it is programmable to calibrate. However, the online instructions on how to do it are, shall I say it, dog's breath. They're translated Chinese and poorly translated at that. So if anybody knows how to calibrate this, I would love a instruction or something. That would be just awesome if you would send that along to me. So as we change the voltage, here we'll drop the voltage. Oops, we'll drop the voltage. You know, 10.3, 2.9. You know, I'm going to say for government work, even if this is right and that's wrong, or this is right and that's wrong, they are close enough. All right, we're going to swap over here and I'll show you the current. Now we're measuring the amperage going through here, and we're pretty darn close. 5.27, 5.3. It's off by 3 milliamps. That's pretty darn close, I'd say. And again, right, same thing. Is this right or is this right? Couldn't tell you, but for my needs, it's way close enough. I'm gonna go down into constant voltage mode or constant current mode. So 2.497 versus 2.5, so off by 3 milliamps. Seems to kind of have a constant theme there. Yeah, it's off by 3 milliamps. Hardly anything to worry about. If we go down, way down, yeah, you know, it's like almost spot on as we get down here low. Of course, I keep saying, assuming that these are the same. All right, so there's 1 milliamp, or 100 milliamps, sorry. Yeah, that's close enough for this government worker. All right, we're going to take a look at the outside of it now. Cooling fan vents here in the front, a nice strap. There's actually a strip of steel on the inside of this thing, so you can pick it up. You can just see it's fairly heavy. Back side of it completely flexible, 100 volt, 120, 220, 230. So wherever you live in the world, this should work. USB port and power back fan, and vents on the other side. So let's take her apart, shall we? Cue the fast music. Hey, there you are, on to the inside. And you can see that the top strap ties into nice steel bar, folded metal outsides. However, the front just ties into the plastic. Honestly, I don't think that's going to be a problem unless you're going to drop it and abuse it. In which case, I don't care how strong you make it, it's not going to be strong enough. Nice toroid. It's been running, it's cooled off, so none of this is very hot. Everything's nicely cable tied. You can see all the power transistors are nicely attached. They've got insulation where they need insulation. They've got the thermal paste can't see it, but there is insulation between this bolt and the base plate, so that's not got a shorted turn, and then it's got this insulation to keep anything from happening or any wearing through of this plastic there. Got the power supply, as Dave Jones likes to say, big clunking switch. The capacitors are Jamicon, 600 microfarad, 63 volt. Looks like they've used Jamicon all the way through. Now I'm going to fire this bad boy up, and let's look at the temperatures that it gets up to when it's running. So hang tight a sec. Okay, we've had this running for a minute. To get it up, it's running at 12 volts, 2.5 amps. And just as a starting point, the base metal temperature 73, 74 degrees. We measure the power transistors, we're at 82. I'll be able to get them all in. 85, whoops, we got an 104 there. I just have to call that out. Something was a little toasty. We're talking Fahrenheit though, so that's 100 degrees Fahrenheit, 91 degrees Fahrenheit, 97 degrees Fahrenheit. Sure what I got that was 104. Now I can't find it. So you can see the little laser, 82 degrees. Something I didn't point out earlier, and I'm not really excited to put my hands inside a running device, but right there, that's where the ground, it's spot welded onto the frame, and that's the green lug on the front. So directly Earth's grounded, mains grounded. Now there's something hot behind that, 105, 113, 14, 15. Yeah, 120. Not sure how high that's going to go. A little closer. These things average the temperatures, so the closer you can get, the better you are for the accuracy of the reading. I think it's going to settle at 121. And found another thing that was kind of roasty toasty is this guy right here. So behind him, 138, 137. So a little bit hot. There's nothing going on over here. These transistors are not active right now. I go searching around, not finding anything hot on here except for that. And there's, if you look carefully, and you can't really see it, but there is a heat sink up there that's keeping it cool. And again, you can hear the fan. That's about as loud as it gets. All right, conclusion. So here at Dogface Electronics, we really like this GW INSTEK GPD-3303S. For the price I paid for it, $200 on eBay, used, open box. If you want it brand new, like I said before, I've seen prices anywhere between $300 to $500. If you're willing to buy something used, they're again on eBay, $100 to $150 depending. So your luck is whatever the luck of the draw is as far as what you can find on eBay. I am really happy with it. I can't foresee me outgrowing this power supply, needing to add another power supply. My workspace is small, so not having multiple power supplies is going to be good. I think this is a quality unit, and it should be, like I said, everything I need for the future. Thanks for watching. Hey, if you liked it, subscribe, thumbs up, post on your social media. Anything to share this for me would be awesome. Thank you.